Okay, let's look at question 5D. Given that f of 1 equals 3, write an expression of f of x that involves an integral, find f of 4 and f of negative 2. Okay, so what this question is referring to is the accumulation rate problems, and this is our equation. This is from page 223. Okay, so we just recently talked about this. So what are we going to do? Well, we're just simply going to write what it's equal to. That is going to be the f of x is equal to 3, which is just f of 1, plus, and we're looking for, well, depends on what we're looking for, so 1 to x. Because we're saying we're starting at 1. If 1 is 3, that's where we're going to start, and then we're going to go from 1 to 3 of f prime of t dt. In other words, this function here represents f prime, which means it represents a rate. So if you integrate this, we find the region under the curve. Right here, they talk about what that is equal to. So this is the answer for the first part. The second part, we're going to substitute in f of 4, which means we're going to solve 3 plus the integration from 1 to 4, f prime of 4 dt. So again, and we can actually think back to the original setup of this question. So if you recall, when we were labeling this picture, we said that this region right here is 12. And so that means that if I'm integrating from 1 to 4, this is 12, right? This is what it indicated in the problem. So this is just 3 plus 12, but again, 12 is in the bottom, so it's negative, so negative 12, and this is going to give me negative 9. Okay? Next part, same thing. It's f now of negative 2, which is going to be 3 plus the integration from 1 to 4 of f prime of negative 2 dt. So this is going to be 3 plus, now keep in mind, I made a little mistake here, this should not be 4, this should be, we're doing negative 2. So if this is negative 2, when we integrate, we usually integrate from left to right, so we're going to go ahead and make this negative. This is going to become negative 2 to 1 f prime of negative 2 dt. So if we look at this picture here, we've said that this is 9, right? From negative 2 to 1, it's 9. So we can say 3 plus negative 9. So, I'm sorry, it's also negative because it's under, so it should be negative 9. So it just becomes 3 plus 9, which is 12. And there you have it. So all we're doing is we're going back to accumulation rates. Because these are under, these are going to be negatives, right? Here, when we rearrange the order, this becomes negative and it ends up giving me a positive result. Hopefully that makes sense, and I will see you guys in the next video.